Greetings everyone, welcome to Math 103 sections 1-1 through 1-3, operations with real numbers. As an introduction today, to discourage random guessing on a multiple choice exam, a professor is assigning 8 points for a correct answer, -4 for an incorrect answer, and -1 if you leave it blank. And with the skills we're learning today, we'll figure out any student's score. And the objectives today, we've got use inequality symbols with numbers, find the opposite or additive inverse of a number, find the absolute value of a number, add and subtract sign numbers, and multiply and divide sign numbers. And it's going to be especially important to pay special attention to those negative signs. We're going to start off with ordering numbers and the less than or greater than symbol. So here's a number line, and as you can see, as we go to the left on the number line, the numbers get smaller. As we go to the right on the number line, the numbers get larger. And we're going to be able to use this number line to order numbers. So first example, I want to place the correct symbol between -5 and -3. So if we look on the number line, you can see -5 is to the left of -3. So that means -5 is a smaller number. Even though the 5 is bigger than 3, when you go with negatives, it's going to be the opposite. So it can be a little confusing. So that's why using the number line is so valuable. So now we're going to place the correct symbol between these two. And when we write these symbols, just keep in mind that the smaller end of the symbol points at the smaller number. The bigger end of the symbol points at the bigger number. Now that brings us to your turn number 1. Now, doing the your turns is an essential part of the learning process. Generally, students will remember a lot more if they do the your turns instead of just watching them. So at this point, you should pause the video, do the your turn, and then restart the video, because I'm not going to pause. I'm just going to go right on to the your turn and demonstrate that one. Alright, so your turn number 1, we're comparing -8 and -12. So if you look at the number line, imagine that -12 is going to be over here, and -8 is here. So that means -12 is to the left, and that's the smaller number. So the small end of the symbol should point at -12. And then we're going to use the greater than symbol there. Because -8 is greater than -12. Now the additive inverse of a number is the opposite. If you look at it on the number line, consider 0 to be the center point. And you can find any additive inverse just by counting the same number over as the original number. So the additive inverse of 4 would be 4 this way or -4. So with additive inverse, all you do is switch the sign from positive to negative or negative to positive. The next example, we've got additive inverses of -4 and 7. So switching the sign on -4 to positive, the additive inverse of -4 is 4, and the additive inverse of 7 is -7. And these will be the same distance from 0 on the number line. So if we count 4 over, 1, 2, 3, 4, we get to -4 and 4. And if we count 7, we get to -7 and 7. So those are additive inverses. That brings us to your turn number 2. You're working on 0 and -3. So 0 is 0 away from 0 then on the number line, right in the center here. So the additive inverse of 0 is just 0. Same distance from 0. And that's the only number whose additive inverse is itself. And negative 3, all right, 3 over here, we're going to go 3 this way to get the 3. And so the additive inverse of negative 3 is 3. And so if we take any number and add it to its additive inverse, we're going to get 0 every time. Negative 4 plus 4 is 0. 7 plus negative 7 is 0. Now the negative sign gives us an additive inverse. So you may see an expression like this. And the negative sign can be read the opposite of. So the opposite of negative 5 is 5. These two negatives are going to cancel each other out. All right, that brings us to your turn number 3. Just remember to pause the video, do it yourself, and then restart the video once you're done. Then you can compare it with my demonstration. All right, so with this one, putting the negative outside, we're going to get the opposite of what's inside the parentheses, and the opposite of what is inside those parentheses is negative 8. So those two things are equivalent. And it's going to be really important to recognize which things are equal to each other, because we're going to be manipulating these things all throughout this class. All right, absolute value. Kind of related to the topics we've been talking about so far. Absolute value can be thought of as the distance from 0 to a number on the number line. Now distances are always positive, so it doesn't matter which way we go. So if I go 5 units to the right, 1, 2, 3, 4, 5, here I am at 5. So the distance between 0 and 5 is 5. So that means the absolute value of 5 is just 5. Now if we're looking at the left-hand side, 1, 2, 3, 4, 5 units over from 0. All right, this has a distance of 5. Distances are always positive. It doesn't matter which direction we're going. So that means the absolute value of negative 5 is also 5 because it's 5 units away from 0. So next example, we're going to find the absolute value of 12 and the absolute value of negative 6. All right, so 12 is 12 units away from 0. You can count over 12 to get to 12 there. So the absolute value there is 12. Now 6, start at 0, 1, 2, 3, 4, 5, 6. That is 6 units away from 0 on the number line. So the absolute value of negative 6 is 6. So absolute values are always going to be positive. If we have a positive value in there, it's going to stay positive. If we put a negative value in there, it's going to switch to positive. So that's the difference between additive inverses or opposites and absolute values. With additive inverses or opposites, we're always going to switch the sign. We go from negative to positive, positive to negative. But with absolute value, your answer is always positive. Your turn, number 4. All right, so negative 9 is 9 units away from 0. So that absolute value is 9. Just strip out the negative. And 0 is 0 units away from 0. So that's just going to stay 0. Absolute value of 0 is 0. All right, now when performing operations with absolute values, Absolute values can be considered to be a grouping symbol, and we're going to be studying order of operations. It's one of the most important topics in this entire course. And the first thing you're going to do in any algebraic expression is to evaluate within grouping symbols first. So evaluate the absolute value first. That's the first thing we should do, is figure out what that absolute value is, and then apply any other operation. So as an example, we got negative absolute value of 13. So order of operations tells us we're going to evaluate this thing first. Don't worry about the negative out here. This is outside of the absolute value. It's not like this. A very different situation here than here. So here, the absolute value of 13, that's 13 steps away from 0, so that is 13. But that negative stays, because that's not within the absolute value bars. Now, as we saw before, the negative of 8 inside parentheses is just negative 8, so this is just negative 13. Your turn, number 5. With this one, it may be tempting to cancel those negatives. Can't do that because one of them is inside the grouping symbols. So we have to work inside the grouping symbols first, figure out what this evaluates to, and then apply the negative. So, absolute value of negative 2 is positive 2. And then just like we did up above, we can remove the parentheses, and that is just negative 2. You can see we get the same answer here and here because, well, not the same answer, we get the same sign, same type of answer, because what's inside the absolute value bars is going to turn positive automatically, and then it becomes negative when you apply the negative on the outside. All right, next topic is adding and subtracting real numbers. So adding, subtracting, you can use your calculators. They're allowed on all exams. It's very straightforward, unless negatives are involved, and that's where I see all of the mistakes, is when dealing with negatives. And as you'll see, using the number line can be helpful in this case too, to keep straight what we're doing. So here's some examples of the type of situations you're going to encounter in this class. So we're starting with -4, and we're adding 7 to it. If we're adding a positive number, that's the same as moving to the right on the number line. So we start with -4, then we move 7 to the right, 1, 2, 3, 4, 5, 6, 7, we get to 3. So -4 plus 7 is 3. And here we got 15 plus negative 3. I'm going to add a few numbers on the end here. So if we're adding a negative number, we're going to move to the left on the number line. So we start at 15, add negative 3, 1, 2, 3, we get to 12. So 15 plus negative 3 is 12. In this case, we are subtracting a negative number. Subtracting a negative is like adding. Let me show you why. Starting at 7, and subtracting has us move left on the number line. But we're subtracting a negative, so we have to move right on the number line. So we're starting at 7, and we move right 3, and we get to 10. So that's why we can rewrite this as 7 plus 3. Whenever you're subtracting a negative, turn it into addition. Part D, you got negative 8 plus 14 plus a negative 1. So we're starting at negative 8. And we're going to add 14. So there's 8, 9, 10, 11, 12, 13, 14. That gets us up to 6. And then plus negative 1. Since we're adding a negative, we're going to go back 1. And we're going to end up at 5. Another way of writing this is negative 8 plus 14 minus 1. You can always rewrite adding a negative as simply subtraction. All right, so negative 8 plus 14 minus 1, and we get 5. All right, your turn, number 6. A, we're starting at negative 12. We're adding a negative, so that's going to move us to the left on the number line. So we're going to keep going this way another 3 spots. Another way of writing this is negative 12 minus 3. That gives us negative 15. So we're starting negative, we're becoming even more negative. Now this one, we're adding a negative, so that's like, or we're subtracting a negative, that's like adding. Negative 18 plus 12. So if we start off at negative 18, move 12 to the right, that brings us to negative 6. All right, next one, we're adding a negative, that's like subtracting. So this is just 23 minus 3, or 20. This one, again, we are subtracting a negative, so that's going to turn into addition. So we got 14 plus 20, or 34. And this one, we're starting at negative 15, moving 6 to the right, that brings us to 9, and then we're subtracting 4. So that's negative 15 plus 6 minus 4, or negative 13. And now this one, we're adding a number, and what is this? This is the opposite, or the additive inverse. When we add those two together, we're going to get 0 every time. Anytime you add a number and its additive inverse, we get 0. All right, now we're going to move on to multiplication and division of real numbers. And there are a couple of very important rules to keep in mind. Again, this is where I see all the mistakes, so make sure you're real careful when dealing with negatives. If we're multiplying numbers with the same sign, any two numbers, x times y, if they're positive, if we multiply them together, they're going to be positive. Or if we take those two numbers, make them negative, multiply them together, those two negatives are going to cancel each other out and it's become a positive number. So whenever you multiply any two numbers with the same sign, it's positive. Now, if you multiply differently signed numbers, say we have a negative, then you're going to get a negative result. So a couple different ways of writing this. You can make the x negative, you can make the y negative, or you just put the negative on the outside. These all mean exactly the same thing. It's important to recognize what's known as equivalent forms. Same way, different ways of writing the same thing. Now we also have the multiplication property of 0. Multiplying anything times 0, any number times 0, is going to be 0. Another batch of equivalent forms is with fractions. And this is something that confuses a lot of students. If we have any fraction, it doesn't matter where you put the negative sign. You can put it on the top number, you can put it on the bottom number, or you can just put it right out front. These all mean exactly the same thing. And the division involving 0, another one where I see a lot of mistakes. Keep in mind that when you have a number, we're going to take 0 divided by a number. That's always going to be 0. Just like multiplying any number by 0 is 0. So another way of writing this would be you can think of it as being like that. Another equivalent form, we're going to get 0 this way. So this is just the same rule we're dealing with multiplication. Tells us that 0 divided by any number is also 0. Now, the other way, though, is very different. Cannot divide by 0. If you ever see division by 0 that's undefined, we're not going to get a result. If you ever forget, just try in your calculator. Try taking any number, 6 divided by 0, you're going to get an error. An error message means it's undefined. All right, so these are the properties we're going to be using now to multiply real numbers. So you should become very familiar with these properties because we're going to start seeing these within larger and larger expressions. So this stuff just needs to be automatic. So we're going to evaluate the following. Evaluate just means to find the value of. And the first one, we got -7 times -2. So we've got two numbers with the same sign. That means the results can be positive. Those negatives are going to cancel each other out, and that is positive 14. For B, we have negative 18 divided by 9. So in this case, we're dividing two numbers with the opposite signs, so that means the result's going to be negative. So that is negative 2. All right, just a reminder, any number outside of a number in parentheses, that's automatically multiplication. Now we're multiplying two numbers with opposite signs, so our result will be negative. That is negative 24. For D, we have division by 0. That's undefined. And then 0 divided by any number is just 0. And that brings us to your turn, number 7. First one, multiplying numbers with opposite signs. 5 times 3 is 15, so that gives us negative 15. B, division by 0, undefined. C, we've got numbers with opposite signs. Those negatives are going to cancel. That gives us 14. Notice that with multiplication, order does not matter. Negative 7 times negative 2 gives us 14. Negative 2 times negative 7 gives us 14. Same answer. 0 over 7, any number, or 0 divided by any number is 0. We've got negative 8 times 3. Opposite signs, so that's going to give us negative 24. And negative 12 divided by 4, opposite signs, we're going to have negative numbers, so that's negative 3. Now, an important part of this class is going to be translating phrases into mathematical expressions. So we're going to start on that today. And I want to introduce some of the key phrases that you'll encounter that correspond with the 4 mathematical operations. So you've got certain phrases that indicate addition, subtraction, multiplication, and division. So make sure you become very familiar with these. This is something you should start studying right away. So for addition, we've got things like added to, more than, the sum of, increased by. Some of these are common sense. You've seen them probably for a long time. Sum, that always indicates addition. Added to, that's obviously addition. Things like more than, increased by, those are a little less intuitive. Subtraction, minus, less, less than. The difference between, difference, that's a big one. Difference indicates that you're going to subtract. If you want to find the difference between two numbers, you subtract them. That tells you how far apart they are. Decrease by, subtract from. For multiplication, we got times. I'm sure you've seen that one. The product of, that one's a little less familiar. So product means multiplication. Multiplied by, or twice, or 3 times a number. Twice, you're going to multiply by 2. 3 times a number, you multiply by 3. And so on. Phrases for division, divided by, the quotient of. Ratio, that's a big one. A ratio of two numbers is You can write that as a fraction. And so what we're going to do now is translate certain phrases into a mathematical expression and then evaluate it. So for example, I want to find the difference between -7 and -18. And when you do the difference, that subtraction, keep the numbers in the same order as they appear in the sentence. So we're going to take -7 appears first, we got -7, and we'll subtract -18. So that's the translated expression. Now we can evaluate it. So we'll convert this into -7 plus 18. All right, subtracting a negative is adding. And we add these together and get 11. Your turn, number 8. What is -3 increased by 16? So we're starting with -3, and then we're increasing that by 16. Increased by is addition, so we'll add on 16 and get 13. -3 plus 16 is 13. All right, another example is the ratio of -63 and 9. Ratio indicates division. So we go -63 divided by 9. We've got a negative divided by a positive, so the answer is going to be negative, and that is -7. All right, your turn, number 9. What is the product of -8? Product indicates multiplication. -5. The two negatives cancel. 8 times 5 is 40, so we get positive 40 is the answer. All right, so now let's look at some real-world applications of operations with real numbers. So go ahead and please read through the example about the Badwater Basin while I make some space on the board. This is kind of an amazing fact, I thought. Badwater Basin, Death Valley, California. It's the point of lowest elevation in the entire country. We got -282 feet above sea level. In other words, 282 feet below sea level. All right, so we've got this basin here. And let's say this is sea level. And then only 85 miles away is the highest point in the entire contiguous United States, not including Alaska. There's some great mountains up in Alaska. But basically, we're just going straight up over here, 85 miles away, and we got this peak here, which is 14,505 feet above sea level. Quite a change in only 85 miles. So what's the difference in elevation between the peak of Mount Whitney and the depths of the Badwater Basin? So to find difference indicates that we need to subtract. So we're going to subtract these two elevations. So we'll start with the highest elevation. We got 14 505. And we can subtract. Now, this is a negative number because it's below sea level. So it's a negative 282 feet. So we need to subtract a negative. Negative 282. And now convert this to addition. So we got 14,505 plus 282. So when we add these two together, see, we got 7, 8 there, there's 7. We got 14,787 feet is the difference in elevation between the peak of Mount Whitney and the depths of the Badwater Basin. All right, that brings us to your turn, number 10, about a cliff diver. So a cliff diver starts at 57 feet. And after diving in, goes down the water and ends up 32 feet below the surface of the water. So what's the difference in elevation between the diver being at the top of the cliff there and finally ending up 32 feet below the water? So difference, again, indicates subtraction. So we're going to do 57 minus, and 32 feet is below the water, so that's actually negative 32 feet if you compare it with sea level. So we do 57 minus negative 32, which is 57 plus 32. That gives us 89 feet. So 89 feet is the difference in elevation from the starting point to the lowest point below the water. And just make sure you include the units in any answers for word problems. All right, now we're back to the example from the introduction, which is to discourage random guessing on a multiple choice exam. Professor assigns 8 points for a correct answer, -4 for an incorrect answer, and -1 points for leaving a question blank. What's the student's score who answers 12 questions correctly, 2 incorrectly, and leaves 3 questions blank? All right, so the student scored 12 points correctly and get 8 points for each correct answer. So we're going to multiply those two things together. The student had 2 incorrect answers, and the professor is going to deduct 4 points for each of those, so we have to multiply 2 times -4 for that one. And then finally, the student left 3 questions blank, so we have to multiply that by -1 point for each one of those 3 blanks. And then we'll add these 3 things together. All right, we got the positive points here, we're going to get negative points here for the penalty, and negative points there for the other penalty. So multiplying these together, we get 96 here, 2 times -4 is -8, and -3. So adding a negative is like subtracting, so we can rewrite this as 96 minus 8 minus 3. So 96 minus 8, that brings us down to 88 minus 3 is 85. So the student's score in this case would be 85 points. Your turn, number 11. So in this case, it's like this professor's a little nicer. Got 6 points for a correct answer, -2 points for an incorrect answer, and 0 points for leaving a question blank. What's the student's score who answers 15 questions correctly, 4 incorrectly, and leaves 5 questions blank? All right, 6 points each for a correct answer. So we got 6 times, the student had 15 correct, so 6 times 15. -2 points for an incorrect answer. There were 4 incorrect answers at -2 points each. Multiply those. And 5 questions blank and 0 points for those. So what do we have here? We got 6 times 15, which is 90, plus 4 times -2 is -8. And 5 times 0, any number times 0, as we saw, the 0 property is 0. Alright, so we'll just leave that off, and we'll go 90 minus 8, going to convert adding a negative to subtraction. 90 minus 8 is 82. So that student's score is going to be 82 points. And that is the end of today's lesson.